Yes, sir.
Okay, today we'll do the next part of the project, um, which uh, which regards with schematic.
Is that like what we've been doing with
Yeah, we for the same circuit we did last time for we it's called the light controller circuit. We'll do the same thing, but using schematic, not VHDL. We did this the code. We used the code last time. But this time we'll do how can we do this using schematic. So for the same circuit, same everything, for the function of the circuit, we'll apply this for using schematic. So again, click on Curtis 2 and create new project, because it will be like a different. Yeah, it's related, but like separate part, and it has different name. So when we click on Curtis, create new project, we can see this window.
Yes, sir, we can see it.
Okay. So click next, and then as this dot, like we did before, new folder. And the name of the project. So we can call it design. Like I mentioned, we'll say like group 14, for example. And SCH, schematic. Then select the folder. So you can see now the name of the project here. So we just write it down here, design. Group. You will put the number of your group, SCH. So let's type it here and there. And then finish. Again, under cyclone, this number here, click, and will change, because will change this family name to cyclone 3. This is which related to our device. Then under choose a specific device and put the name of the device we put before, which is EB3C 16 F4 84 C6. So it's filtered. We have a lot of names here before. So filter to our device. And then you just hit OK. So now you can see the name of the related to our device. Then under File, New, and now we'll choose for schematic. So you can see here,
Block diagram slash
yeah,
file.
exactly. So you choose this and hit OK. So we can see this window. Then File, Save As. So design, the name of the project here, dot PDF. For now, for this part, we need to put dot PDF. Save. So we can see the name here. Now you can see the symbol here. You see the symbol for gate. Now we need to draw the circle, like multi-sam, for example. So we click on this symbol. And then click here. Then click on primitives. And then logic. So you can see the gates here. So if you go back to the circuit, we have two AND gates, we have one OR gate and the two inverters. So we choose AND with two inputs. First, we can start with AND gates. And gates with two inputs. You see we have different inputs here, so we need this one. And OK. We need another one, so we say OK. And then to get rid of this, just hit escape. Okay. Then again, click on this symbol and go to OR gate. We need one OR gate with two inputs, OR, OK. And escape to get rid of this. Then we need two inverters or NOT gate. So NOT gate, okay. So you can put it here and here and skip, but we may need to move it a little bit to allow space for the inputs. And then we go back and you need to click on bin to choose the input and the out. So input here, okay. So we need two inputs, X1 and X2. Escape. And we need one output. So output here. Okay. To connect it to the OR gate. Now we connect these. We connect the circuit. So when you put the cursor at the edge, I mean at the end of the component here, until you reach to the edge of the other component. The same thing here. You see, we have something here, not good. Okay, so delete this. Let us move this little bit. Okay. Then we also can connect the output here. We can do that. Okay. Then we'll call this X1. You can double click here and say this X1, double click, and call it X1, input X1, double click, X2, at the output, double click, and say F or G or whatever, or Y. But I just put it F like the circuit we have. Then X1 is connected directly to the first gate. So for the first gate here, we take wire and then connected to X1. X2 connected directly to gate 2. To one of the inputs of gate 2. So we can do something like this. And then we take wire like this. And then we connect this upside. Okay. So X1 applied to one of the two inputs of the first AND gate. X2 applied to one of the two inputs of the second gate. Then X1 inverted goes to the gate 2. So like X2 inverted, X1 inverted goes to the second input of the second gate here. And X2 inverted connected to you can modify your circuit as you want. And then we take this, the wires here are different than multi-sim. You have to take it like piecewise, piece by piece, like this, and you have to go like this, and then you connect. In multi-sim, oops, we have bad connection here, so delete it. In multi-sim, you can take the wire, go through the circuit, so it doesn't. It's different. You can double check. So here you have to take it piece by piece. Then one of the outputs of this AND gate goes to one of the two inputs of the OR gate. I try to make it organized as much as I can, but of course, the important thing is just make sure we have good connections. Okay. So we draw the circuit. So after we draw the circuit, um, and we code the inputs and the output. What do you think? What is the next step?
Run the simulation or?
Compilation.
Hmm.
So just to make sure the connections are okay. So here, this arrow. Yes, okay. So you can see here moved from step to another step until the whole compilation completed. So if the circuit is okay, nothing disconnected or nothing wrong, so it will give us successful completion. If we have something wrong, we will receive a message and we have to review the circuit. Just review. So like you have wire, you wanted to make sure this wire connected or not, just drag the wire. So if it is connected, it will keep connection. But if it is not, you will see one leg not connected. So for completion was successful. Of course, you need a screenshot for all of this, for the circuit and for this message of full compilation. So, okay, and close this. And now we go to new file, new, and we go to university program. Okay, like we did before, but this for the schematic. And the files save as, you will call it design as we used. I use G14 here, schematic, SCH, and the dot VWF, full wave file, and save. Now we'll do the same thing. What we do, who remember what is the next step?
You
Edit,
run the
edit,
simulation.
Did we
edit.
change the times, the length of the
Yeah.
simulation?
So we click on edit, insert node bus.
Are we supposed to be seeing another window or?
It's here. You see it here. You see this or not?
Think so. I
What
mean,
do you
my
mean?
screen is different because I have like another window.
You see what I'm doing here?
I see the schematic.
But now we have another window for VWF.
I don't see that.
You don't see that?
It's
No.
not showing the waveform editor.
Uh, okay, let us go ahead a little bit and see if you can see it or not. So we can say, okay, Oh, we have error here. What happened? So we said edit.
Don't we need to do like node finder?
Yeah, insert a node. Yeah, and click node finder, right? Okay, you don't see this? And the list? You see the inputs and the output here?
No,
It's very strange. So how you see the other one and you don't
because
see-
because I remember it from last time.
everyone does not see this like X1 and X2 and F node finder?
No,
No,
it's
I don't see it.
no.
I think you need to like change the screen share because I think you're only screen sharing
I
like
have
this window.
I have problem with the other screen, unfortunately. So, but we'll do the same steps now. Up to this moment, this schematic now, this schematic is corresponding to the code of the last time. So we continue the same steps to do simulation. So we put the inputs, we move the inputs, the input and the output, we move the list to the other side, like click on the double signs here, and then OK. So we, and then OK. Okay. Then edit, set end time. So we use 4 because we still have just 2 inputs. So 4 microseconds, okay. Then edit, grid size, 1 micro. Again, be careful because here we have nanoseconds. So it changes to micro. Then click on X1, the input X1, and the click on overwrite clock and put 4. 2 to the power 2 is 4. So 4 microsecond, okay.
Can you
And
say that again? Click on X1 in
X1, highlight X1 and click on, you see the symbol with the clock?
Oh, right. It's overwrite clock.
Yeah. And choose 4. Then highlight X2, do the same thing. Now 4 divided 2 is 2. 2 microsecond. Okay. So now we figured out the inputs and the out. I mean the inputs. Sorry, the inputs X1 and X2. So we have 0, 0, 1, 0, 0, 1, 1, 1. Based on the different combinations which we listed in the truth table. Now click simulation options and choose Curtis 2 simulator. And then OK. Say OK. Then again, simulation, and click on run functional simulation. Yes. So start, you don't see anything so far? I mean,
No, sir.
oh, so you can get the simulation now. So you can see the inputs and the out. So 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0. Like we got last time. But after we draw the circuit, you do the same steps as before. We do the same steps, like we choose for VWF, we call the file .vwf, and then edit and put the times and like we did last time. All groups done the first part.
Professor, can you show what the waveforms look like? Because I can't get them to show up on mine.
Oh, okay, just let me ask this question. Did all the groups finish the first part or not?
Which first part?
Which first part? For the VHDL, the code.
No,
Using the code.
not for our group.
Why? Which group not finished?
Group
Which
2.
groups and why? Why why you leave it for up to today? Why? You should do it immediately.
Professor, you did not tell us that we should do it immediately.
What is that?
You did not tell us that we should do it immediately.
I didn't what?
You did not say that we should do it immediately.
No, I mean at least when you went home, it's better to do it because the best thing to work with me. Like I some people work with me, so it's better to work with me. But if not, at least when you go home, do it.
Yeah, you're right.
Yeah.
Professor,
Yes.
I have a question. This
Go
is for 1 and 2. When you click simulation, run functional simulation,
Mhm.
is this supposed to make another window that has like a
No,
graph?
it will appear in another window. The simulation will appear in another window. The result, yeah.
Yeah, I can't get that.
Why?
I don't know. It just like doesn't work for me.
Did you choose before simulation? Because this happened the last time too, for you. For
Yeah, it's Cordis 2 simulation.
simulation, did you choose Curtis 2 before
Yeah.
options? Did you
Yeah.
choose option first
Yes.
and choose Curtis 2?
Yes.
Then if you go back and simulation and run functional simulation, you should get the results.
Yeah, it doesn't really work. It doesn't do that.
Okay,
I don't know why.
so I have groups finished here. Yeah. Okay, good. Um, okay. Let us take like 10 minutes break, hoping to see what happened for the screen for the other screen to show you these waveforms. So like just 10 minutes break and we'll come back. Okay. do you see the screen now?
Yes.
Oh, I see it.
Yes,
Oh,
sir.
okay, so this is the result, how it looks like. As I mentioned, like we did before, the same thing.
Oh, okay. So this is the result. So
Yeah, this is the inputs and this is the inputs, and then after simulation, we got this one. So 0, 0, the output is 0. I mean, x1, x2 are zeros. F is 0. X, one of the two inputs is 1, and the other one is 0. So the output is 1. The output is 1. Then both of them once. So the output is 0. Similar inputs, 0 out.
so if I just screenshot the waveform editor for
Yes,
the
this is the
input and
end of
output
the.
waveforms.
This is the end of the. If you reach to this simulation result, yeah. So this is the end of the second part of the project. Like also the first part, we should reach to the same result for the first part when we use VHDL, when we use the code instead of schematic.
Okay. And I want to be clear. This is the only window, right? There's only one window, the simulation waveform editor.
Yes, this is the result. I mean, this is the result. So we can see the result of simulation here. We can see the inputs here, the two inputs, and we can see the schematic here. You see all of this or not?
I think so. Yeah.
Okay.
There's two.
What do you mean by I think so? Either
No,
yes or
I'm just
no.
really confused
Why? Why confused?
because
This is
I
the
don't
schematic.
know.
You see the schematic or not?
I see F, X1, X2, and I see all the things we said.
And
Like
the
how we
gates. Do
set
you
them.
see the gates connected?
No, you're only sharing the simulation waveform editor.
No. I'm talking about the schematic. The circuit.
No.
Okay. But when we draw the circuit before, did you see how we draw it?
Yeah.
Okay. So this is the schematic, which when we did compilation and we get successful compilation, okay? And then we see the waveforms and then the output, the simulation, the result of the simulation. Do you see the result of simulation here or not?
No, that's what I'm confused about. Cause like when you
But
press
you told me I
simulation,
see it before. You told me I see it.
what?
You told me before. I see the output waveforms here. I mean the result of the simulation.
Because I was confused what that was. I didn't know if it was like the editor or was a different window.
Anyone see the simulation here? The result of the simulation, like for x1 and x2 are zeros, the output waveform is 0 for F.
Yes.
You see it?
Yes, I see it. You mean like on your screen or my own screen?
On my screen. You see it?
Yes, I see it.
So what's wrong with you, Josh? You confusing me.
I don't know. This is very confusing.
Yeah. Who else sees the waveforms here?
Professor, I had the same problem, and sometimes it just doesn't work. And I think if you redo it again, it is just better. But yeah, same as Josh, I wish we could solve it right now.
When you click on simulation, did you choose options first?
Yes.
Before run,
Yes.
you need to choose option.
100%. I copied you exactly
Okay,
one by one.
I'm talking to the. I asked the other friend also
Okay.
to make sure. I know you did that. Okay, before you did that, did you do you click on compilation for the circuit? Did you get the message for successful compilation?
I did.
And you got the message.
Yeah,
Right.
yeah.
Okay. Then did you follow the steps which I did, such that you reach to the two inputs, x1 and x2?
Yes.
Okay, so what you missed is just the simulation. So when you click simulation, you need to choose options first. And when you click on options, you have two options. The one on the right side is mentioned Curses 2. This is our option we choose. Then, so you click on this option, and then you go back to simulation again, and you hit run functional simulation. You should get the output waveform. Of course, the output is the input. Okay. 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 Okay, let us do it again. Okay? Okay, guys? You hear me?
Yes, perfect. That's great.
Yeah.
Okay, let us do it again from the beginning. Please work with me and focus, please. So we click on Curtis. You see create a new project. Click on this. You see the windows or not?
No, you're showing your camera
No,
right
you're
now.
showing your camera.
Okay, let me just 1 second.
Professor,
Yeah.
could we like walk it through with somebody else screen sharing to like walk
Ju-
them through it?
Just 1 second, please. Just 1 second. Let me see. Okay. Do you see the screen now?
I see it.
Okay.
Yes.
Okay. So please just follow me. So everyone sees the screen now, right? Okay.
Yes.
Unfortunately, I have problem with the other screen. Needs some time to see what is the issue. So since you see this way, that's fine. Bless you.
Thank you. Sorry.
Okay. So what we do, like we mentioned, let me just close this. Oh, okay. Okay, just 1 second. Okay. So you see, create a new project. Do you see this?
I see it.
Josh, do you see it or no?
Yes, yes, Professor. I like understand how to do it. I just don't like. I'm good with this.
Okay. Okay. Because someone asked to do it again, so it's okay.
Yeah, that's fine.
So create a new project, then next, then click here. So new folder, open new folder, and just put the name of the project. So design, group 20. Okay, so this is just new. Okay. Design, group 20, SCH. Select folder, so you see the name here. Write it down here, design, group 20, SCH, then finish. So you see now the name of the project here. Everyone sees this?
Yes.
Okay. Now we need to change the name here. So the family name. Our device is Cyclone 3. So we choose Cyclone 3. And then click on specific to filter these names here and put the name of the device, which you mentioned, EB3C 16 F4 84 C6. So now the filtered for this one. Then click OK. So we have the new or the Cyclone, the name of the family for our device. Then we mentioned we open new file, new, and as your friends mentioned before, we choose a schematic file. So highlight this and say OK. So you get this window. Everyone sees this window?
Yes.
You see this gate here?
Yep.
Yes.
I see it.
Click on this. We need, based on our circuit, we need to draw 2 AND gates and 1 OR. I mean, we need to drag 2 AND gates, 1 OR gate, and 2 inverters. So click here, choose primitives, choose logic, and then go to AND gate with 2 inputs. You have AND with 12, 3, 4, we choose 2. Okay, so we put 1 here and 1 here. And to get rid of this, just escape. Again, we need 1 OR gate. So we go down until we reach OR with 2 inputs. Escape. Then we need NOT gate. We need not gate, so we choose not gate. So we put one here, and the organization is based on you. I mean, whatever you feel better, just do it. Then we need inputs and output bins. We need 2 bins for inputs and 1 bin for the output. So we click on bin, and you see here input. So we choose input. We need 1 here for X1 and 1 for X2. Escape. Then we need 1 output. So we put 1 output here. Escape. And you can give names for the inputs and the outputs. So we have X1 and X2. So we just double click here and write X1. Double click here. Double click here and put X2. And as the bin name here at the output F, put F or Y, whatever. Then connect. So connect this and little adjustment here. Connect this. You see we have something bad here, so we have to delete it. And we can connect to the output here also. Okay. So X1, if you look at the circuit, X1 goes to the input of one of the 2 inputs of the first AND gate. So X1 connected to the first gate here, the first input of this gate. X2 also goes to, okay, it's okay. Goes so X1 applied to the first gate, X2 applied to the second gate, then X1 inverted goes to the second gate. So and X2 inverted goes to the first gate. Then the outputs of the AND gates goes to the OR gate, to the inputs of the OR gate. So okay. Oh, you see, this is not connected. So we need to connect this. Yeah. And then the other one goes here. Okay. So we connected the circuit. To make sure the circuit connected fine and nothing wrong, so we have to click on this arrow. This arrow, you can see for compilation. Start compilation. Everyone sees this?
Yes.
So click on this. Okay. Yeah, yeah, we have to call this .bdf. BDF. See. We should name it design schematic.bdf. So you see this message here? Full compilation was successful. Forget about warnings. This doesn't matter. You should get this message to complete. If you have anything wrong, you have to go back to the circuit and see where is the error in the connection. So far it's clear? The one who asked it is okay?
Yeah, it's clear.
Okay, so say okay, close this window after you get screenshot. And then we go to File, New, and choose VWF. Okay. You see this window?
No, it's not on your
Oh.
screen.
This window for like choosing the inputs before we do simulation. So I don't know why you don't see it. But from now up to the end, we do the same thing we did before. Like we choose X1 and X2. We start with edit and insert node, and you continue as we did before. So we click on insert node and we choose node finder, and then click on list. So we see nodes, the nodes we have X1, X2, and F. Click on the double arrow here. So you move to selected nodes, and then you click OK. Then OK. Now we click on edit, set end the time. So we mentioned we choose 4 microseconds. Oh, okay. Then edit, we choose grid size. Click on the grid size. We use 1 microsecond for the grid. 1 micro, not none, micro. Okay. Then we highlight X1 and we click on, there is a symbol for like a clock, which is overwrite clock. Click on this and we choose 4 micro for the first input, 4 microsecond. Okay. Then highlight X2, do the same thing, choose 2 microsecond. Click OK. So we have the inputs now. Now we have the inputs. Let me try something here. Can you see it now? Can you see the input waveforms?
No, unfortunately not.
No. Okay. So I just continue. So click simulation, options, use Curtis 2. Okay. Okay. Then simulation, run functional simulation. Yes. And just put the name, the new name, design. Design G20. SCH dot VWF. VWF. And save. Yeah, so simulation is running. So you got the out. You got everything now. The we have the input waveforms, but after simulation, we got also the waveform of F or the out. This, as I mentioned, after we reach to the schematic, we do the same steps like we did for VHDL, because this part is the same. Until we get the simulation, the same steps. The only difference in the first part until we get simulation. The difference in the first part, we use the code for VHDL, so we have different names for the project, like the extension. And the second part, we use the schematic. Okay. Who got this part?
What part?
Any group got the second part? I mean, okay, good. So please, you can communicate with each other too. I mean, it's, yeah, other groups can communicate with each other. And I post the tutorial for this project. So until we reach to the schematic, the rest is the same as we did for the first part. It's the same. So go ahead and if you have any question, tell me, please. Because this by the end of this part, we should done. And fortunately, we covered all what we need based on our course schedule. So we covered everything, including this last task here. So let me say this. We have another class on Thursday. This Thursday, everyone hear me?
Yes, sir.
Yeah.
Yes.
We have class on Thursday because I give like more time for the project if you need more time. But my part is done. I mean, I explained both sides. But of course, if you have any question, you can ask me. So if you like to come next on Saturday is okay. Because we will take the final on August 5th. It's next week. next week on Tuesday, we'll take the final exam. So if you don't need anything, we can take like next class, like review break. You can take it break to review for the final. If you are okay with that.
That's fine, Professor. So you're saying that attendance is not required on
No,
Thursday?
no, on Thursday, no attendance.
Do we
If
still
you
get a
are
check
not
mark if we show
coming-
up?
If you are not coming, I am not coming too. So, but if anyone will come, I will be here. Okay. But as I mentioned, we done our part. Okay, and fortunately you covered everything. So you may take next Thursday as break to review for the final. Then we have the final on August 5th. Then we have another session on August 7th. But if everything is this also for the project, if everything is okay, so we by finishing the final exam, so we are okay. So no need to come on August 7th. But if still a work left, we come on August 7th. Okay. So now let us take it part by part. Okay. So the first thing. Do you like to come on Thursday, or you like to take a break for the final exam, to review for the final exam?
We should review for the final.
You take break.
Review.
I want to come for review, final exam review.
No,
Oh,
if-
is there a
If you
review?
if you take break, so will not come. No one will come. If you agree with this, you see.
We
what
should review on Thursday.
I mean, review at home. For
Aw,
for the
okay.
final, it will cover. For the final, it will cover. Let me just 1 second. Let me. So for the final, we will have parts 8, 9, 10, 11. Just 4 parts. Because we already in exams we covered the rest. But we still need to cover something in 8. So 8, 9, 10, 11. Parts 8, 9, 10, 11. Okay. This for the final exam. So just go through the slides and review the examples we did together. If you have any question, you can send me or ask me. But if you like to come, welcome. It's up to you.
So sorry, just to double check. If we come on Thursday, what are we going to do?
Nothing. We should work on the project. The rest of the class meetings we finished before I mean we covered the material before, because this okay, let me explain. The regular class is 15 weeks. Okay. The regular class 15 weeks, but each class like around 2 hours. And one time per week. One time per week. So this is 10 weeks for summer, 10 weeks, and each class 2 times per week. So like we have 20 equivalent to 20 weeks of the regular one. So that's why we finished before we reach to the end of the August 7, for example. You see what I'm saying? So that's why I bought the rest of the class meetings for the project, like more time. But one of them is for the final exam. So what I'm saying, I explained the projects, which is the last part. Okay. If you wanted to still to come on Thursday for the project, okay, I will be with you. Okay. But if you prefer to stay at home and review for the final, and suppose you finish the projects too, so that's fine. The final, we have the final on August 5th. Consequently, we don't have to come in August 7th because the last day is August 7th. So if we finish with the final and you finished everything, so we don't have to come August 7th. But if there is still anything left, we can come on August 7th. So we have up to August 7th. But again, as I mentioned, because we have like more time for this based on the distribution of the class meetings, so we finished by today. We finished the material by today.
Okay,
So it's clear or not clear?
it's very clear. I would prefer to stay home.
So if you want to come on Thursday to work on the project again, but I explained it like more than 2 times. So it's up to you. It's up to you. It's based on your decision. So what you prefer?
I'll stay home.
Yeah, I'll just review myself.
Everyone will stay at home?
Yes.
Or-
Yes, we'll just do the review on our own that day.
Yeah.
Okay.
Professor?
Everyone agree with this?
Yes.
If anyone does not agree, please chat with me. Just to know. If anyone does not agree about this, just chat with me. If no one mentioned, I mean, if I didn't receive any message from anyone, this means everyone agreed to stay at home on Thursday and like to take more time to review for your final exam. Again, the final exam covers just 4 parts out of 11 parts. So 8, 9, 10, 11. So this is what we will have. That's what we'll include in the final exam. Similar to the slides examples we did. So if we are not coming on Thursday, so definitely we will have the final exam next Tuesday. Next Tuesday, August 5th. So everyone must be here. Everyone must be here for the final exam. Okay. So the first question. So everyone agree to not coming on Thursday?
Yes.
Yeah.
Yeah.
Anyone has other
Yes.
anyone has other opinion? Just chat with me right now. Okay, to decide.
Will you still do your office hours this week, Professor? Just, I mean, if we
Emily,
email to
you have
ask
high
about it,
echo.
for example?
I don't hear you. You have high echo. You can chat with me if you like. You can chat with me.
Okay.
She asked if you were going to be in your
sorry.
office hours, Professor. Until the end of the class, probably.
Today? Yeah.
No,
Well, I
no,
mean,
no.
like until the end of the class. Will you be still be in your office hours?
No, that's not what I asked. I'm sorry,
Okay,
Okay.
it was kind of echoing.
Thank you, Josh.
I'll just email. If I have any questions, I can email.
Yeah, you can email if you have any question. And even we can arrange something if you like. Okay? Okay. So okay. So this means on Thursday we are at home. Okay? And the final exam will be August 5th. When we meet for the final exam, we'll talk about whatever next. Okay?
Okay.
Yes, you can email me. What is that? Who's speaking?
Is the final exam online?
I don't hear you. Can you chat with me?
Yeah, is the final exam online?
Yeah, like we did the midterm and the quiz.
Okay.
Same thing.
Okay.
Will it be the whole class,
Who asked this?
Arthur? Is it gonna be the whole 2 hours?
Arthur, are you with us? I mentioned parts 8, 9, 10, 11.
No, I mean, is it gonna be the whole class
For
period?
the time. I'm sorry. Do you talk about the full? Yeah, there is no class. There is no lecture.
Okay.
So when you finish, you leave. Yeah, sorry. I thought you talk about which parts. Yeah, parts 8, 9, 10, 11. And yeah, is the whole session for the final exam. So when you finish, you can leave. So we don't have lecture. Or we already done. Okay. Any other questions, guys?
Yeah, Professor, can I ask a question about the project?
Yeah, Josh, go ahead.
So when it says screenshot of the input waveform and screenshot of the output waveform, can I just use one screenshot for both of those?
It's embedded, okay, but I just want to make sure everything is fine, because if you don't get the output, so at least you have the inputs. You see what I'm saying?
No.
Okay. Say you did simulation and you didn't get a result for any reason. For any reason, it may happen, right? So you have the phase before that. Because if you just put the last one, so you combine the two screenshots in one. You see what I'm saying? Okay. It's included, but I am worried about if you don't get F. So you have at least the two inputs before. But if your screenshot, your final simulation is okay, and you got everything right, it's okay. Yeah. It covers the previous one. Got it, Josh? No? Yes?
I guess. I'm not very confident though.
Okay. If your simulation is complete and everything is fine, it's okay. You can put just the screen, the final of simulation. Okay. But for any reason, if the simulation doesn't go through or what happened, so at least you have the two inputs before. A screenshot for the two inputs before.
I see. For each part. Okay.
For each part, if you didn't get the final simulation correctly. Okay.
Okay.
It's
Thank you,
clear
Professor.
now. It's clear. I just
I
wanted
think
to.
so.
I wanted to guarantee a credit for you for whatever you did. Okay.
I want to. How would you like
Just
us to?
like one put final result without the steps. So if the final result is wrong, he lost everything. But if there is a steps and the final result is wrong, so he or she will get credit for the steps. That's what I mean. Okay.
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 Do you want a conclusion like the labs or no?
Of course, yes. Any project
Okay.
or lab, you have to put conclusion for your work.
Okay.
Professor?
You may like here, you did two different techniques. I mean, using the code and using the schematic. So which one you believe is more better or more practical than the other, and why? For example, you may say, I am cheating you. Yeah, I see the schematic, for example, is more convenient for me because I don't have to write a code and check the code every time. Because writing
Yeah.
a code, I believe writing a code is not easy for everyone, like drawing a circuit. And if the circuit gets complicated, so this means the code will be more complicated. However, you can draw whatever circuits, just drag the components and connect. So this like one may see or one may have different view. He or she may like more coding, so may say something different. Okay, so it's up to you. This is your view, your conclusion for what you did. And of course, I understand all different point of views. I understand this. It's not like yes or no, or yeah, this is correct, this is wrong. No, it's based on what you see and the reasons you mentioned for this. Got it, Josh? You see what I'm saying, Josh?
Yeah. I got
Okay.
it. Thank you.
Please, if some people has different schools than Nova, can you chat with me with your school? Because I have question for you. If anyone came from another school different than Nova, because we have some students from outside. So just to put your school name, because I have question for you.
In the assignment?
No, in the chat, before we do. Okay, hold on. Okay. Okay. The people from Virginia Tech, I think you studied this Curtis too. You used it in the school.
Yeah, but we used Verilog instead of VHDL.
Oh, okay. And you didn't use the schematic?
We did, but like they provided the schematic and then we just had to write code.
Okay. Okay. I have another question for you. Does the student use like reference sheet in the exams
Like a cheat sheet?
or cheat sheet, whatever,
We didn't have exams.
in Virginia Tech?
Do you mean for this class or for like other classes?
No, for any other classes. Any other classes.
Oh, any other class?
Most-
Yes.
Most EC classes, yeah, we got.
You use cheat sheet?
Yes, a lot of classes have them.
Not every class or all classes or
It
courses.
depends.
It depends
like-
on what. It depends on what.
Math classes
It's
typically
different
don't.
classes. Yeah,
Ah,
math classes don't, like physics classes do have a cheat sheet.
physics and the math.
Math
and-
doesn't, physics does, yeah.
But other classes, no?
I had a cheat sheet for another EC class at VT.
What's your school, Mermin?
Virginia Tech.
Mm. So you use the cheat sheet also for like beside the math and physics may be used for other courses too?
Yes.
Mm. And is there constraint on the cheat sheet?
Like a page, typically, a page or two.
One page, and are you allowed to put anything or just the formulas or?
They let you put like everything except solved problems, typically.
Mm. Oh, okay. So it's just like phenomena, you know? Okay. I thought like in certain schools only, but it seems other schools other than Virginia Tech do the same thing. Hatter.
I don't get that many of those options at Old Dominion. It's
Old
very
Dominion?
rare. It's very rare that I get something like that. Occasionally,
So do you mean you have cheat sheet or no?
typically no.
Oh no. Mm.
Typically no. Sometimes
It's
like,
not
there's
allowed.
occasion. Usually no. Occasionally there's a class that you can have them, but not
Okay,
often.
Like, what do you mean by occasionally? I mean, is it
Um,
different courses or?
Yeah, different courses.
Mm.
So
you say, I mean, still something exists, right, about it?
yeah, depending. Like
Mm.
so
But not
my
too
math
much.
classes would absolutely not let you have that. Like that would not happen in math. That would not happen in physics. Some of the coding classes will occasionally,
Mm.
if depending on how they give their test, but
Mm.
not typically.
Okay. Any other schools also have?
Professor,
Yes.
sorry for interrupting. Are we free to leave now?
What is that?
Are we free to leave? Has the class ended?
You talk about the end of the class today?
Yeah.
Yeah, we're done. If you don't have question, we're done.
Thank
Okay,
you,
just one
Professor.
quick,
Have
yeah,
a nice
one
evening.
quick question. So the final project, that is a group project, right? So
Yes.
only one person submits.
Yes, group project, group submission.
Okay, thank you, sir.
All members, please work together, guys.
Thank you.
And you have expert people here also. I mean, you can communicate with them. Also, I mean, group discussions with other groups is okay. Like, yeah, you have Arthur, you have Los. So, and of course, with me, if you have any question. But sometimes the students like to ask their friends more than asking the instructor. But of course, I am your friend and welcome for any question anytime.
Okay, thank you.
You're welcome.
Okay, have a nice day, Professor.
You too. Take care.
Thank you.
Thank you, man.
Thank you, Professor.
Thank you, Professor.
Thank you. Take care, everyone. You too. Take care. Bye.